Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video describes how to conduct two-tailed hypothesis testing for linear correlation using StatCrunch. Let's get started. So, in previous mini lectures where we talked about hypothesis testing, we exposed ourselves to a methodology for testing a claim. And we can use that same methodology for testing a claim that two variables are linearly correlated to one another. So, as we've seen before, hypothesis tests can be one-tailed or two-tailed, and that's the same thing we've got here for linear correlation. They can be one-tailed or two-tailed. Typically, our hypothesis testing is going to be two-tailed. The reason for that is because the claim that we make is simply one of linear correlation. So we're not specifying a particular, type of linear correlation. So we're not saying it's positive or negative. We're just saying just straight out plain linear correlation, which means it could be either way. It could be negative on the left or it could be positive on the right. And so therefore that makes the test two-tailed. Of course, if we do specify we want positive linear correlation, or we specify negative linear correlation, then the test is going to be one-tailed. Here's some notation that we need to be aware of when we're doing hypothesis testing for linear correlation. N, of course, is the number of pairs in sample data. That's our sample size. And the little letter r is our linear correlation coefficient for a sample. Greek letter rho, I know it looks like a P, but it's really a Greek letter rho, is the linear correlation coefficient for the population. And then hypothesis testing for linear correlation has the same three requirements for establishing linear correlation. So as long as we've got those requirements met, we can use our methodology for testing for hypothesis testing. So for two-tailed hypothesis tests, which is typically what we have, we're going to form a hypothesis just as we've done previously. The null hypothesis will be a statement of equality, and so we're going to set that population parameter for the linear correlation coefficient equal to 0. That means that if the null hypothesis is true, there is no correlation between our variables. The alternative will then be that the population linear correlation coefficient is not equal to 0. So it could be negatively correlated or positively correlated. So the null hypothesis, if it's true, means there is no linear correlation. And that's where we are on our scale there. So we're right smack dab in the middle if the null hypothesis is true. However, if the alternative hypothesis is true, then that means there is linear correlation. And so we could be on the right or we could be on the left. It could be one way or the other. So it's just a matter of, which way the hypothesis test is going to take us. So our quote-unquote test statistic is going to be our linear correlation coefficient. And then we can evaluate the test by comparing the R value we get from our data with the R value from the critical value table. And again, we've seen this from the previous mini lecture. If we clear the bar, then we conclude there is sufficient evidence because we rejected the null hypothesis. However, if we didn't clear the bar, we fail to reject the null hypothesis, and therefore it could be true, we say there is no linear correlation, or there's not enough evidence to support the claim of linear correlation. Of course, the quote-unquote test statistic is not the true test statistic. The true test statistic is a t-score with n-2 degrees of freedom. So if you're asked to calculate a true test statistic for any of your problem statements, you got to go to your t-calculator and or actually just use this little handy-dandy equation here. The other way to get it, I think, is with the ANOVA table there in StatCrunch, but we'll look at that in a moment. So if you're doing this by hand the old school way, here's what you're going to use to calculate your true test statistics. So the R value you get from your data goes in here, and then of course n is the sample size, and you turn that all out in your calculator, and out comes your test statistic. You then can use that with your t-distribution calculator in StatCrunch to find your p-value. Remember, typically you've got a two-tailed test. So here in this example, we're just looking at a one-tailed test, so it's there on the right, but it's the same concept. So you've got your in fact, you could actually say this is a two-tailed test. If your significance level is 5%, just take half of it and put it in one tail, and you're going to get the same boundary as you do if you got two tails there. So there's your test statistic. Therefore, a two-tailed test with 5% significance level, 2.28. And then you can, you use either way, the test statistic or the p-value to evaluate your test. So if you're inside the critical region, reject H0. Outside the critical region, fail to reject H0. Goes the same way that we've always seen. Inside StatCrunch, there's a single menu option series that can provide most of what you need. So to Stat, Regression, Simple Linear. So here in your options window, select your X and Y variables. And then that's all you really need to do for just simple linear correlation. Just select your data and then hit compute, and out comes your results window. And you read the values right off the results window. So here's your linear regression correlation coefficient. Here's your R-squared value, the explained variation or coefficient of determination. Your p-value, notice you're taking the p-value off of the slope row and not the intercept. Okay, that's the same as the the p-value you see down there in the ANOVA table. But if they ask you for the true test statistic, take the one that's there for the slope. Don't take the one out of the ANOVA table. Of course, scatter plots come out of the regression analysis as well. So you don't need two separate menu options to get what you need. Just make one. If you see that you're going to need regression analysis with your problem as well as the scatter plot, then just go to regression analysis, get that done. Then in the results window, notice here how it says 1 of 2 up at the top. Well, that means you can click on this arrow down at the bottom to see a second page. When you do, you get your scatter plot. So you don't need to make a separate scatter plot. Just go through the menu options, with just the one that you see here, and that'll be sufficient. So lazy engineers rule the day. I remember once we were listening to this vice president of engineering at this Fortune 500 company I used to work for, and he told us in this big meeting, he said, "I love lazy engineers." And we're all looking at each other like, what did he just say? And he said, "Yep, you heard me right. I love lazy engineers." And he then began to explain why he said that. And he talked about these engineers he knew who were making this computerized model of this process, and they spent 3 weeks trying to get every little nook and cranny right so they can get an exact answer. And yet he could spend 5 minutes with pencil and paper and get an answer that's not exactly right, but it's close enough to the exact answer to be workable. He said you wasted 3 weeks worth of work for this increased accuracy that doesn't do you very much. Just take the 5 minutes, be lazy, take the 5 minutes and run through the simple calculation and then move on. Just get good enough and move on. And so that's what I like to do. When I'm working in StatCrunch, I like to just use the menu options that let me press fewer buttons so I can be more efficient with what I do. And I call it being lazy, but yeah, it actually is being more efficient, being smarter about the way I work. So I recommend that to you. If you can find ways to get the same answer with less effort, hey, more power to you. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.